Okay, so let's go over 19 through 24. Number 19. We want sine in terms of cotangent. Now, are sine and cotangent on the same Pythagorean identity? No, they're not. So we have to use the Pythagorean identity of cosecant squared equals cotangent squared plus 1. And I want cosecant on the left side. That's why I wrote it this way. Okay? So cosecant squared equals cotangent squared plus 1. So you change cosecant squared into 1 over sine squared. Then you have to take the reciprocal of both sides. So sine squared equals 1 over cotangent squared of x plus 1 and take the square root of each side. Now, the square root of 1 is 1. The square root of cotangent squared of x plus 1 is the square root of cotangent x squared plus 1. And since we can't leave a square root in the denominator, we're going to bring it up to the numerator by multiplying both the top and bottom by square root of cotangent squared of x plus 1. So your final answer should be sine of x equals plus or minus cotangent squared of x, square root of cotangent squared of x plus 1 over the cotangent of x squared, or cotangent squared of x plus 1. All right, cotangent in terms of cosecant. Cotangent in terms of secant, I mean. So the one that involves secant and something like cotangent is tangent squared of x plus 1 equals secant squared. So then what you have to do is subtract 1 from each side of this. So if I subtract 1, tangent squared equals secant squared of x minus 1. Rewrite tangent squared as 1 over cotangent squared equals secant squared of x minus 1. Do the reciprocal of each side, and then just like the last one, take the square root of 1, and then take the denominator, which is the square root of secant squared x minus 1, multiply both the numerator and denominator by that, so we get the square root off the bottom. So the cotangent of x equals positive or negative. It's square root of secant squared of x minus 1 over secant squared of x minus 1. Tangent in terms of cosecant. Well, I don't have tangent and cosecant together, but I have cotangent squared of x plus 1 equals cosecant squared of x. So then I move the 1 to the other side. Rewrite cotangent squared as 1 over tangent squared, take the reciprocal, and basically the same operations as we did in the last two problems. Okay, and then I don't need to show 22, do I? Because it's the same thing, type of thing. So 23, tangent of x equals 1/2. So the first thing you find is cotangent. Cotangent is the reciprocal of it, which is 2. So then what I said is, well, I know the cotangent, let's find the cosecant. So cosecant squared equals cotangent squared of x plus 1. Cosecant squared equals 2 squared plus 1. Cosecant squared equals square root of 5. So cosecant of x equals square root of 5. I found that. And you know the reciprocal of cosecant is sine. So if sine is 1 over square root of 5, can't leave square root of 5 on the bottom. It's square root of 5 over 5. Okay? Then, if I have tangent as 1/2, I can find secant squared. So 1/2 squared plus 1, or 1/4 plus 1 is square root of 5/4, which is the square root of 5 over 2. So secant of x equals the square root of 5 over 2. And the cosine of that is the reciprocal of that, which is 2 square root of 5 over 5. Since it's in quadrant 1, they are all positive. They are all positive. And the last one you had to do. We're in quadrant 2. Whoa. We're in quadrant 2. So since we're in quadrant 2, and we know the sine of x equals 3/4, that is positive. All right, let's remember this. All three, sine, cosine, and tangent, are all positive in quadrant 1. In quadrant 2, cosine and tangent are negative, sine is positive. In quadrant 3, cosine and sine are negative, tangent's positive. In quadrant 4, cosine's positive, sine and tangent are negative. So in quadrant 1, all three of them are positive. Sine in 2, tangent in 3, cosine in 4 for being positive. Okay, if you can remember that, we're good. Okay, sine of x equals 3/4. Whoops, meant to have the highlighter out. Undo. So if the sine of x equals 3/4, the easiest one to get is the cosecant of x equals 4/3. Now, if the sine of x equals 3/4, I know sine squared plus cosine squared equals 1. So you take 3/4 squared plus cosine squared equals 1. So 9/16 plus cosine squared equals 1. Subtract 9/16 from each side. Cosine squared equals 7/16. Cosine of x equals the square root of 7/16. So the cosine of x equals square root of 7/4. So it's negative square root of 7/4 because cosine is negative in quadrant number 2. So if I know that, then I can find secant. Secant is 4 over square root of 7. So multiply top and bottom by square root of 7. So secant is 4 square root of 7/7. And then really cosecant is a fairly nice number here. So I'll use the cosecant cotangent one to find cotangent. So cosecant squared equals cotangent squared of x plus 1. So square it and then subtract 1. And then take the square root of both sides. So the cotangent of x equals the square root of 7, negative square root of 7/3. So the tangent's the reciprocal of that. Another way to find tangent is you can put sine over cosine, which is 3 over negative square root of 7, which if you multiply top and bottom by square root of 7, you get 3 square root of 7, negative 3 square root of 7/7. Okay? So, are we good with those? All right. So, moving on to odd and even functions. Here we go. We're told on our note cards that the cosine of negative x equals the cosine of x. Why is that? Well, we know the cosine of 0 equals 1. And the cosine of pi over 2 equals 0. That comes from our unit circle. If we'd go the other way, the cosine of negative pi over 2 would also equal 0. Because remember, our cosine curve went like this, like this, like this, and so on. Okay? So, whether it's a positive or a negative, it's going to be the same answer here. So if I go over a positive amount of pi, the cosine at pi is negative 1. The cosine of negative pi is also at negative 1. When everything is a mirror image around the y-axis, when everything is reflexive with the y-axis and symmetric with the y-axis, where you can just reflect over the y-axis, then it's an even function. This is called an even function when it's symmetric over the y-axis. Okay? So the cosine of a negative number is the same as the cosine of a positive number. Okay? That's what an even function is. All right. An even function is like y equals x squared, or y equals x to the fourth. 0, 0, 1, 2, 2, 4, and so on. Negative 1, 1, negative 2, 4. So whatever it is on the x side, it's the mirror image of that across the y-axis on the y side. Whenever you have even powers, that's why it's an even function. Okay? When it's an odd power, then it is a reflection. So we reflect across the y-axis, and then we're going to reflect across the x-axis. Reflect across the y-axis, then we're going to reflect across the x-axis. When you do a double reflection, the sign of a negative number is going to equal negative sine of x. The sign of a negative number equals negative sine of x. So the sine of 0 is 0. If you reflect it across the y-axis and the x-axis, it stays there. Nothing happens to it. So at pi over 2, the sine of pi over 2 is 1. The sign of negative pi over 2, the negative of that, is the opposite sign. Okay, why? Because if we reflect, and then we reflect, it's down here. Okay, reflect, reflect. So, the sign of a negative is the opposite of what it was when it was positive. Okay? So that's, if it's a negative here, it's a negative out front here when we find it. Okay? So at 3 pi over 2, the sign at 3 pi over 2 is negative 1. So the sign of negative 3 pi over 2 should be what? A positive 1. Okay? Just the opposite. Just the opposite. Okay? So, let's work on simplifying odd and even functions. What's the sign of negative x equal to? Negative sine of x. What's the cosine of negative x equal to? It's just the cosine of x. The negative just drops out, basically. What's the tangent of negative x? Well, this comes from your note card. Or also the fact that sine over cosine equals tangent. So a negative over positive is a negative. So the tangent of negative x is negative tangent of x. And what's the cotangent of negative x? Negative cotangent of x, because it's cosine over sine, and a positive over a negative is a negative. Okay? So we got rid of all the negatives out of the parentheses. Now what we're left with is negative sine of x times cosine of x. And we're going to turn tangent into sine of x over cosine of x. And cotangent into cosine of x over sine of x. Any simplifying I can do? Yep. This sine can cancel with this sine. This cosine can cancel with this cosine. So it's negative sine of x, cosine of x. That's our final answer. That's what it simplifies to. What's cosine of negative x minus cosine of x? Well, to start this problem, we have to figure out what cosine of negative x is equal to. What is cosine of negative x equal to? Cosine of x. What's cosine of x minus cosine of x? Big fat 0. Okay? What's the sine of negative x minus the sine of x? Well, what's the sine of negative x? Negative sine of x minus the sine of x. Negative 1 sine of x minus 1 sine of x is negative 2 sine of x. Negative 1 sine of x minus 1 sine of x is negative 2 sine of x. What would you do first here? Figure out cosine of negative x. So cosine of negative x is cosine of x, right? So it doesn't change anything. It's 1 minus cosine of x times 1 plus cosine of x. Now when we have two sets of parentheses like that, we have to think of what? The 4-letter F word. FOIL. You people and your dirty minds. We're talking math here. 1 times 1 is 1. Outers and inners are going to cancel. And then negative cosine times cosine is negative cosine squared of x. What's 1 minus cosine squared of x? Sine squared of x. And that's fully simplified. Let's do one more here. Well, at least one more. Maybe we'll do a couple more. How would we simplify this? First step. It's the negative sine of x, right? And what's minus a negative? It's a positive. And the other one becomes 1 minus sine of x. So then we FOIL this, and we get 1 minus sine squared of x, which is cosine squared of x. Follow that? There you go, 27 through 38 all. This will not actually take, well, the first few problems will take a little while because the first few problems on the assignment, numbers 27, 28, are 2 of the problems where we ended with last time, where you have to figure out the 5 trig functions and then work through odd and even functions on 29 through 38.